This is a worked solution to AQA Physics P2 June 2014 higher tier paper question 3. Force A is the force between the tyres and the road, and this is caused by friction. Force B, the arrow representing force B, is the air resistance. The graph in 3A part 3 is a velocity time graph. It shows that the gradient of the graph gradually decreases. This means the acceleration is decreasing until the gradient is completely flat and zero, when the acceleration is zero and the velocity is constant. We're asked to explain, in terms of the forces A and B, why the velocity changes as it does between x and y. So between x and y, the acceleration is decreasing. And this is because the cyclist is getting faster and air resistance is increasing. So we can say at x, force A is greater than force B. Because the push from the pedals is greater than the resistance forces against it. Because we have an unbalanced force, the cyclist accelerates. But then we say, as this happens, force B, which is air resistance, increases. This makes the resultant force smaller. And as the resultant force decreases, acceleration decreases. So the velocity increases at a slower rate. From Y to Z is when the air resistance is increased to the point that it becomes equal to force A. So there is a zero resultant force, and we can tell the zero resultant force because the velocity becomes constant. And Newton's law states that when the resultant force on a body is zero, it remains either at rest or moving at constant velocity. So from Y to Z, force B increases until it is equal and opposite to force A. Acceleration decreases to zero. And the velocity becomes constant. It could state this is called the terminal velocity. B part 1 asks us to calculate the work done when a force of 140 newtons acts over a distance of 24 meters. So the work done is force times distance. In this case we take 140 newtons times 24 meters, and that gives us a work done of 3,360 joules. When the brakes are used, the bicycle slows down. Question 3b2 is about energy conversion. So the kinetic energy of the bicycle, because it's slowing down, the kinetic energy decreases. And that kinetic energy is transferred to the thermal energy of the brakes, which makes the temperature of the brakes increase.